This is lesson 27-1, and we're going to be taking a look at implicit differentiation. Implicit differentiation is taking the derivative of an equation other than a function. So we've only looked at functions so far, like y equals blah blah blah, and we've taken the derivative of that. Well, we're going to be taking a look at equations that do not represent a function, and we're going to have to take the derivative of it. We're going to also be using the concept of that differential that we used in the previous lesson for us to be able to do this. So here are a few helpful steps. First, we want to find the derivative of the entire equation in respect to x, because that's typically what it's going to ask us. We're going to use algebra to solve for dy over dx, because it's what's going to want us to find. It's going to ask for it. And then if a solution is required or given, we're going to use it. So in this first statement, it says find the equation of the tangent line to the circle x squared plus y squared equals 4 when x equals 1. So we're finding an equation of the tangent line. Well, I need to know the slope and a point. So to find the slope, I'm going to have to use the derivative, right? I'm going to have to find dy over dx to find what that slope is. Now to find the point, x equals 1, I can plug in 1 for x, get y by itself, and that's going to give me the point. So I'm going to do that real quick. So 1 squared plus y squared equals 4 minus 1, y equals plus or minus root 3. In this instance, the positive root 3 is going to be associated with the positive 1. So my point is going to be 1 root 3. So now I need to find the slope. So to find the slope, I need to find the derivative of the equation. So dy over dx, or take the derivative of everything. So d over dx to x squared plus d over dx to y squared equals d over dx to 4. Well, the derivative in respect to x squared is 2x. The derivative in respect to x of y squared is going to be 2y dy over dx. And then the derivative in respect to x of 4, it's just a constant, I get 0. So I took the derivative of everything. Now my goal, what I need to do, is I have to get y or dy over dx by itself, because that's my slope. So let's get that by itself. So I'm going to subtract 2x on both sides. So I get 2y dy over dx equals negative 2x. Then I'm going to divide both sides by 2y. So I get dy over dx equals negative 2x over 2y. Now, this equation here, that represents my derivative. So the value for x and y at that particular position is going to give me the slope. So that's going to be negative 2 times 1 over 2 times radical 3. And so for here, the 2's are going to cancel out, so I get negative 1 over root 3, which is the same as negative root 3 over 3. That is my slope. So now finding the equation, y minus y1 equals my m times x minus x1. And so I now have an equation of the tangent line. Example number 2. Find dy over dx of e to the y minus sine of y equals 2x. So taking the derivative of y as respect to x, so the derivative of e to the y is e to the y, but the derivative of then that y is going to give us 1 dy over dx minus the sine of y. So the sine of y here is going to give me derivative of the outside, so we're going to get cosine of y times the derivative of the inside. Well, the derivative of the inside of y is just 1, but I get my dy over dx, and that's going to equal 2x. Well, the derivative of 2x is 2. Now I need to get dy over dx by itself. Well, if you notice, it's in common here, so I can factor out the dy over dx. Divide both sides by that, so I get dy over dx equals 2 over e to the y minus cosine of y. And that's going to be the derivative. For this one here, find dy over dx. So for this first statement, the derivative of the first times the second plus the derivative of the second, I have to have my differential, times the first, plus, now the derivative of x is just 1, and that's going to equal 0. So now I need to get my dy over dx by itself. So first I can subtract that. I can subtract the 1. So I get 2y dy over dx equals -1 minus 2xy squared. Then divide both sides by 2y. You get dy over dx equals -1 minus 2xy squared over 2y. So implicit differentiation is for scenarios in which our equation is not a function. And so we're going to be taking the derivative of y as well, but it's going to simplify into dy over dx in those different scenarios in which we know how to take the derivative, right? We have the power rule, we have the quotient rule, we have the product rule, chain rule, we did some trig functions, we had some exponential functions. So all of those things are going to apply, and we just have to be aware of that. This does conclude our lesson. If you have any other questions, please leave them in the comments.